under box and whisker plots. The box / whisker plots. Okay, and again, remember the first thing you're supposed to do is order from least to greatest, which I believe in this case was 10, 11, 10, 11.
I told you the wrong thing.
15, is that surprising? 16.
Sorry.
3 17s.
Who's the 16? Oh yeah, that looks like you. Picture that right.
2 18s, 2 21s, and a 34.
Okay, technically my
So
sister is 9.
What? Did I miss the 22?
Yeah,
you did put it.
Okay. Sorry about that.
Oh no, we don't mind. Take your time.
Okay, so the deal is this. The first thing you want to do is make a number line that has that. And the lowest was 10, and we need to go to 34. So you've got 10, let's do it like this. 20, 30, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could have made it a little
I
better.
like my box.
Step number 1.
Does anyone have a match?
Step number 1. Listen, please, because this will come up here. Find the median. We have what, 13? So number 7 is actually the middle. 1, 2, 3, 4, 5, 6, 7. So your median is 17, which I believe is what, 19, 18, 17. You should have drawn straight up and down the line there. That's the median. The first quartile is what you get when you find the middle of the left side here, which is between 15 and 16, which is 15 and a half. 1, 2, 3, 4, 5 and a half. So you got, this is your lower quartile. 15.5 is your lower quartile.
We don't have to label them, right?
LQ. No, but you need to know what they are. Your upper quartile is right here between the two 21s, which happens to be 21. Okay, that's quartile number 3. And then you put a whisker here at 1, 2, 3, 4. And you put a whisker here at 10. And that's what yours should have looked like. My box is a little goofy, not really the best there. Now, I told you, you know what an outlier is. An outlier is something that's way outside the norm, and it's obvious that this is going to be an outlier because it's so much bigger than everything else. But there is a mathematical formula that you need to use in math if you're actually finding the exact thing. Because math, nothing is really subjective. It needs to be objective. You need to be able to figure it out. So here is the formula to find outliers. Here's what you need to write down for today. That is if I can
Should we
figure it
just
out.
go to outliers?
Well, you want to put it under, you want to probably put it under box and whisker plots, I would think. Or you could go to outliers and say see box and whisker plots. Whatever you think works best for you. You are your own boss there. Oh look, I could have put all this stuff way up there. Here is the formula for finding outliers. Like that color. Outliers. To find an outlier, to see if it's an outlier, here it is. Don't worry, I will find it here. An outlier. You have to take the here's I'm going to give it to you in the mathematical formula they give you. When x when x is less than q1 minus 1.5 times the IQR. And I'll talk about all of this in just a second. Or when x is greater than
Holy cow.
Q3 plus 1.5 times the IQR. Does that help?
I don't know IQ is.
Exactly, and that's what we're going to talk about here.
IQ.
But write this down because this is part of the whole spiel about here. Okay, first things first. Okay, you know what Q1 is. Q1 is the first quartile, which was this right here. That was the 15.5. Q3, you know, is the right here, which was 17 or 21. Those are those numbers there. Okay, and what you're looking for is this part right here, which is what you would subtract from that to tell if something was an outlier. And how you find this number here, the IQR is called the inner quartile range. The inner quartile range. And what that is how big, it's this range from your LQ1 to your Q1 to your Q3. It is just, you just need to subtract Q3 or Q1 from Q3. You want to find out what the range of numbers inside your boxes is. How many units is it? So you just take 21 and subtract 15.5 from it. So 21 minus 15.5 is, ladies and gentlemen, who said it? Somebody said it. 5.5. What that means is this. Oh, once you find that range, you have to take 5.5 and multiply it by 1.5. Okay, when you take 5.5 and multiply it by 1.5, what's that? 2, 25, 27, 0, 5, 5, 0, 5, 2. This number here, ladies and gentlemen, 8.25 is how far you can go this way before something becomes an outlier, or how far you can go this way before something is an outlier. Okay? In other words, this. If you subtract 8.25 from this 15.5, that'll tell you how far down you can go before something would be called an outlier. If I take 15.5 and I subtract 8.25 from it, I end up with 7.25. Okay? If I find a number that is smaller than 7.25 over here, if I were to come up with a 7 or a 6, you wouldn't count those because those would be called outliers because they are this far smaller than your first quartile. In the same way, if I take 8.25 and add it to my 21 plus 8.25 is 29.25. Any number bigger than 29.25 is an outlier and would not get thrown into the mix there. So I actually wouldn't put my 34 there. I would actually go only to the 21 point there. And I don't think do we adjust, I don't know if they adjust it or not actually, afterwards or before. Third quartile is 90. And again, it's pretty complicated really. It's not hard, it's just a little bit confusing, I guess, is the deal. Okay, Steph?
If we figure something's an outlier, do we have to do the entire formula?
Well, that's what I was I'm gonna say at this point, I don't know.
you could pretty much figure that 34 was gonna be about. Yeah. It was like 5, 6, 7, 8, 9.
Okay, what it says here is this. They did the whole thing. When they did an example problem, it says, in a box and whisker plot, outliers are represented by an asterisk and not included in the whisker. Okay, they're not included in the whisker. In other words, this. The book did this. They got rid of this part of the line. Whoa, they did this. How big is this? Okay, they got rid of the whisker, took out the outlier. That meant this 21 was that 22, sorry. 22 is where the new whisker goes, and then you put an asterisk there where the outlier was. So your graph, I believe, stays the same. You just don't make the whisker go out there and you put an asterisk there to show that that was an outlier. Because otherwise you would have to redo the whole thing, right? Yes, you would. You good with that? No, they kept it, they did another one where they kept it all the same. Now, just to give us a little bit of fun and excitement with that, I have gone to great lengths, very great lengths, to give you a little practice with this. What I want, you want a shot to try to figure out outliers on your own, or do you want me to go over to another example? Yeah, you can do everything on here, but before you do that, let's make that stem and leaf plot, just because it's a good review for us. Dost thou remember stem and leaf plots? If you don't, I will help you with that as well. I gotta find out where it's at here. Oh wait, hold on a second. Insert file. If you know the stem and leaf plot stuff, go ahead and do it. Otherwise, I will give you the quick review here before we get to it.
Yeah.
What was it? What was this under?
Can we just look at our notes?
Yeah, sure. Oh, okay. I'd love for you to look at the notes. How do you make a box in this thing? That's not gonna be it, is it? Nope. Oh, here it is. And just making the stem and leaf plot would just make your life easier later on. How many people actually remember these stem and leaf plot business? I thought as much. The deal with the stem and leaf plot is simply this. The leaf is always the last digit. The stem could be a bunch of digits, but in this case, since these are all only 2-digit numbers, it's only going to be 1 digit in the stem, 1 digit in the leaf. You start by this. Okay, here is your stem. There is your leaf.
Is this our
Well, I do have something else. Don't worry, Kel. Okay. For the stem, you just look to see what are the numbers in front of the leaves. Okay. It looks like it goes, what, 50s to 80s? Is there any 90s?
5, 6, 7.
Right, so you put them in order, 5, 6, 7, and 8. Those are your stems. And then you just go through this, 89, and these need to be in order, so I put a 9 over there.
Why are we putting it over there?
72, because if there's an 86, 85, or 84, it needs to go before the 9. 79 would go over here with the 9. 60 at first because it's a 0. 51. 54. 60. 89. 67. Another 60, 60, 58, 56. Wait, I knew it was 77, 55. And a 78. So realistically, if I'm doing this, I would put all these,
Oh, not devices.
well, you can move them however you want. It don't has to be. I'm just moving them close so I can see them better. So there is your stem and leaf plot. Love it. Now, do you remember about a histogram?
What?
Histogram is just like a stem and leaf plot, except you turn it on its side. It's a bar graph that just does this. You'll remember this. Histogram tells you the frequency of each number. In other words, okay, this group goes from what? It goes from 50 to 59. So your first column here is going to go from 50 to 59. Oops. Your second column will go from 60 to 69. Third column is 70 to 79. And then your fourth one, your last one, is 80 to 89. And what you are saying in your histogram is how many numbers fall in that range. In other words, what's the most we have? In the 50s, you have 1, 2, 3, 4, 5. So your vertical scale, your horizontal scale, you would have 5 lines. 1, 2, 3, 4, 5. Yes, I love your volleyball coach.
Coach Costa, she like just in random, she's like, psh, and it's like perfect. It's all like,
So in the 50 through 59 category, you have 1, 2, 3, 4, 5 numbers. So you would draw a bar graph that goes up because it's 5. You have 5 numbers in that range. In the 60 to 69 range, you only have 4. So it would only go up 4. In the 70 range, you have 4. And in the 80 range, you have 2. That is your histogram. It's a good review. Then, ladies and gentlemen, kids of all ages, I will allow you to make your stem and leaf plot. I mean your box and whisker plot. You can do that one on your own and check for outliers. Does it appear there would be an outlier here? 89 might be, I don't know.
But there's no, does that make a difference?
Well, I don't know.
It goes from 79 to 89, that's
I don't know. You would have to, it goes from 51 to 89. It all depends on what your median is. It depends on what your interquartile ranges are. I'll let you figure that out.